Hi there, welcome to this quick clip on volumes of 3D shapes. Let's have a look at one or two shapes and see if you can recognise what they are. What sort of shape would you say this is? I was going to ask our camera guy, but I think he's got mal de gauche a little bit, so maybe he's not too sure. What sort of shape would you think that was? You can see either end of it there. It's going to be any ideas?
Hold on.
Is that the name of the shape? Hold on?
No, it's a can.
A can! Yeah, fantastic. Wow, you can tell how long we've been rehearsing this. This is called a cylinder, alright? A cylinder. Okay, it's a can. God. Yeah, it is a can, he's right, but we call it in maths, we call it a cylinder. Any ideas how we work out the volume of a cylinder? How much space is inside a cylinder? What do you think it's going to depend on? Look at that beautiful drawing there. What's it going to depend on? What would you say? The volume, the amount of stuff we can get in there, the amount of soup or whatever it is that we can get in there is going to depend on how, what's the word for that? How? Yeah, go on. How? If it was a lot, then we'd get a lot. Yeah, the length of it or the height of it. Yeah, that's good. So the higher the can, the more you'd get in it, yeah?
Definitely.
And what about this? It would also depend on the
surface.
Yes, the area of this. If it was a great big thing, we'd get more in, wouldn't we?
Definitely.
So what it works out at is, it's priceless, the guy we've got today. The volume of a cylinder is actually the area of the base, yeah? And what's the formula for the area of a circle? Pi r squared, multiplied by the height of the can, alright? So it's the radius, there's the radius from the middle to the edge, it's pi times the radius squared, that gives you the area of the bottom, yeah? So pi times the radius squared gives you the area of that, and we multiply that by the height, and that gets us the volume. So it's pi r squared times the height. That's a formula that's on the inside front cover of your exam paper. So let's do an actual example. Let's say we had a can where the radius, yeah, was, let's make it say 2 centimetres. So the radius is 2 centimetres and the height is 10 centimetres. Let's have a go at working out the volume of that can. So what we're going to say it is, the volume is pi times r times r times h. Is that right? When I say pi r squared, is that right, do you think?
Definitely.
Fantastic. So pi is 3.14, the radius is 2, the radius is 2, and the height is 10. So we've got to double 3.14, which is 6.28, yeah? Double it again, that's 12.56, and multiply that by 10. You can check whether I'm right there near, I reckon that's 125.6 centimetres cubed. Remember, because it's a volume, it will be in centimetres cubed. Have I done that right? 3.14 doubled, 6.28, double again, 12.56, times by 10, move the point along one place, yeah? 125.6 centimetre cubed. Is that alright?
Very good.
Fantastic. Let's have a look at another shape now. Have you any idea what sort of shape that would be? What we would call it? That sort of shape.
Sphere.
A sphere, fantastic. That's a sphere, like a football. Okay, so let's say we had to work out the volume of a sphere. This isn't a circle.
Football.
Pardon?
Football.
Like a football would be a sphere as well, wouldn't it? Yeah?
Okay, a football.
Yes.
All right.
What did you think I said?
Football, the team of a football.
Ah, right. No, a football. No, I won't say anything about your team there. It's not fair to be rude. Yeah. But no, the ball itself is called a football, yeah? And it would be a sphere. So if we want to work out the volume of a sphere, the formula for that, which again is on the inside front cover of your exam paper, is 4/3 pi r cubed. Alright? So let's say we had a ball, let's say we had a sphere which had a radius of 2 centimetres. Let's have a try. So we've got a radius of 2 centimetres and we want its volume. So you tell me if I'm doing this right. I reckon it would be 4/3 times pi, which is 3.14, times 2 times 2 times 2. Yeah, because it's r cubed. So 2 times 2 is 4, times 2 is 8, times 4 is 32. So we've got 32 times 3.14 and divide by 3. Okay? So 32 times 3.14, if this was on the paper where you're not allowed a calculator, we're going to get a bit of long multiplication here, just see if I'm doing this right. That's going to be 9, 2 4s are 8. You be trying this at home or at school just to make sure I'm doing this okay. Without your calculator, if you could, that'd be fantastic. And that's going to be 2 decimal places, 100.48. Okay? So we've got 100.48 and we've now got to divide that by 3. So a bit of long division here. 3's into 10 goes 3 times, remainder 1. 3 times, remainder 1. And 3's into 14 is going to go 4 times. And that's going to be about 49. So it's going to be about 33.49, and this would now be centimetres cubed, because again it's a volume. Alright? Does that look as though I've done that right there, would you say? Or are you a bit speechless at how quickly I've done it?
I don't understand why you should be on pi r to the 3.
You
Why
don't
it's not-
understand why it is?
Yeah.
Okay. The reason
Why
it's-
not to the square?
Sorry?
Why not to the square?
Okay, you've asked a good question. The answer is because when you try and work it out, that's what it depends on. But that's not a very good answer. To work out any volume, can you see if we go back to the cylinder? Although that was r squared, yeah, we then did times by height. So we had like a length and another length and another length. Can you see that? We had like a length and a length and a length. So there were like 3 lengths involved, yeah? Because we've got r squared, r times h. So there were 3 measurements involved, yeah? And it's the same with the cube, sorry, the same with the volume of the sphere, it's still got 3 things involved, alright? And there always are if you've got a volume of a shape, alright? It will always end up having 3 things multiplied together, 3 lengths. You think back to a box. What about the volume of a box? That you'd have done that back in primary school. How do you find the volume of a box like that? What would you do?
Length and breadth times length times width.
Times height. Yeah?
Yeah.
So can you see again, there's 3 things involved.
Different.
So it's L times W times H, length times width times height. 3 measurements involved. Cylinder, 3 measurements involved. Sphere, 3 measurements involved. Alright? You see, there's no real height with the ball, it's to do with the radius of the ball or the radius of the sphere. Okay? Now, what about if we had a question on a cylinder like this? Let's suppose they said, yeah, let's suppose you got a question that said, what's the volume of paper in this cylindrical shape? What do you think you'd do? The volume of the paper in the cylindrical shape. Let's assume it's nicely packed tightly together. What do you think you'd work out firstly? You'd work out the volume of the
Circumference.
you'd work out the area of the whole lot and multiply by the
Height.
height, and that would give you the volume of the big cylinder. Yeah. Now, what do we have to take off? Because we only want the volume of the paper. So what do we have to take off? The clue is what I'm pointing towards you now. You'd have to take off the volume of the
Middle one.
No idea. Right. We want the volume of paper here,
Okay.
yeah? So what we're going to do is work out the volume of the big cylinder, work out the volume of the small cylinder in the middle, because that's just empty space, isn't it? Yeah? I can see you through there, yeah? Yeah? Can you see?
Yeah.
Okay, I can see you, you can't see me, yeah? So we've got to take that off. So we do the volume of the big cylinder and we take away the volume of the small cylinder. Does that make sense?
Definitely
So
not.
it's like having this can of beans here, but with a hole in the middle, yeah? So if we wanted the volume of the paper there, yeah, we'd do the volume of the big cylinder by doing pi r squared times h. We'd do the volume of the small cylinder by doing pi r squared times h, and we'd take the 2 away. And that would then leave us with this, the volume of the paper that's here, yeah? All the way down. You get the idea?
Fantastic, yes.
Fantastic. Superb. Alright then. Thanks a lot for watching. Hope you found that useful.